Hi everyone! This time I would focus on what truly looks like a devlog, as the title of this channel suggests. It will be about shaders again, but instead of creating it from scratch, I would dissect a fog effect as we implement it in our game. Let's do it. Our game, Whispers of Prague, is a 2D point-and-click adventure game, so the mist effect we added to some scenes is located in the 2D layer as a texture rect, and we render it right after the background of the scene. Let's take a look at the respective scene and its node tree in the Godot editor. So I will switch here to first start and we can see it right here. This is the fog node after background, and I'll switch to 2D editor and we can observe it in action. This is the final effect, exactly as it appears in the game. Let's now temporarily disable the visibility of the background and hotspots to see only the fog itself. Background and hotspots. Here it is. As we can see, it's not just a simple mist. Our effect consists of 3 layers that we've animated in various directions, resulting in a much more spatial impression and allowing real-time modification of the mist through parameters. Moreover, from a programming perspective, it's a very straightforward solution that can be used for any 2D game where, for example, we'd like to simulate drifting clouds over a tile map. Now, let's finally take a look at how this mist is generated. I'll click here at the fog node, and in the inspector we can see that the texture rect is defined using a noise texture, which is one of the great features of Godot that we use very often in our game. You might remember that I used the same type of texture in one of the previous videos to simulate an animated 3D shield. If I click on that texture, its parameters appear, and we can see what parameters were changed to fit our specific case. The first one is called seamless. Because we don't know in advance how long the player will stay in the respective location, it's necessary to ensure that the texture repeats indefinitely and that individual tiles seamlessly connect with each other. This is achieved through this switch and also the repeat property in the texture section. Let me scroll down to here. Yeah, texture, repeat, and set to enabled. The second one is normalize. As the tooltip suggests, turning off normalize is recommended when we want to reduce the chance of the texture becoming too visibly repetitive over time. If we try to activate this switch, we can see, let me just switch there and do it. If we try to activate it, we can see that the mist has become slightly more contrasty and could be more prominent in the scene than we would like. Therefore, in our case, we decided to turn it off and just keep it in this configuration. However, for some cases, normalize may be a better solution. It depends on your project and decision making. The third one is noise. This is the actual noise generator, and if we click on it, we can see additional parameters from which we only change the frequency. The reason was that in the default settings, the mist looked more like clouds in the sky. Let me just try that. Yeah, I think it could be probably usable too, but we just wanted to do it this way. So in our case, we are following this approach, and if, for example, we will be working on a top view game, we would choose the cloudy solution. Is that all? Of course not. We are just at the beginning. If we were to deactivate the material for the moment, let me scroll down, find the material and just click here. Only this texture would be displayed and the result would be unimpressive. Therefore, for the texture rect, we created a new shader material. Let me just revert that, and this is the shader material we created, and this is it's basically responsible for the entire fancy animation. Let's take a look at how such a shader is implemented. I'll click there and open the shader editor. As we can see, the code is really simple and only takes 14 lines. However, if we didn't want to work with layers and group the color variable settings into one command, we could get it down to under 10 lines. The foundation of the mist is its color, which we set by this uniform parameter. It's a simple trick because the noise texture only contains shades of gray, so all we need to do is multiply the corresponding pixel by the base color at the end of the calculation. We can try changing it in the inspector, so I'll just switch back to show the mist and open shader parameters. Let's click the base color and change it to something different. Wait a minute. Okay, and how about this one? Interesting. This looks like quite a toxic mist, doesn't it? Of course, if I put the background back, faint green shades won't be too visible on green background. But if we opt for something more towards purple or red, let's try it. We can create quite interesting effects. A vivid red might be suitable, for instance, if a level of your platformer were to traverse hell or another infernal territory at that stage. Combining such an effect with a suitably modified fireworks display, as shown in one of the previous videos, could evoke the impression of a volcanic landscape. There are truly plenty of possibilities. Okay, let me just revert it back. Wait, 1, 2, 3, 4, 5, 6, how many changes? Yeah, this is it. Okay, and let's put the background back. It looks definitely better. So, how do we calculate this effect? Let's switch back to the code and take a look. In the code, we can see that we are fetching the corresponding pixel from the noise texture. This is the texture just bound to the texture rect, which is using this shader material, and the texture function, which is taking the particular pixel on these coordinates. And using the internal variable time to shift the coordinates in certain direction to achieve the desired animation. We have these lines for 3 mist layers, and finally we combine them using the mix function right here, which is nothing but a linear interpolation between 2 values, just like we call the lerp function in GD script. So right here we mix the color fog color 1 and fog color 2, and the result is mixed again with fog color 3 with different weight values. Now we can easily look at the individual layers and the direction of their movement. So let me just show the effect again, disable the background, and if, for example, I replace the result with only fog color 1, let's wait for it. Yeah, this is the first layer, which is going slightly to the left and down. Let's see the second layer, sorry, and the third one. Okay, and these 3 layers of fog are mixed into the final result, which looks, I would say, pretty nice. And if we revert it back to its original state, which is this one, we can notice that the individual layers aren't as prominent as when they were displayed separately. That's precisely the advantage of the mix function, which allows us to achieve a transitional effect and blend all parts of the mist nicely together. Similarly, we also modify the alpha value in the following line, right here, to achieve variable transparency. And what is the location fade on the very last line for? This way, we perform a smooth fading of the mist until it completely disappears, which is an event that occurs in the game after a certain action is performed. By this, I don't mean that the protagonist of the game dispels the mist with some magic. It's simply a weather change after a certain amount of time has elapsed. I can demonstrate that. So let me just switch back to background and do it in the game. Okay, maybe it was a bit faster than I expected, but we were able to observe how the fog dissipated within the first second of the demonstration. We can see it right here in the code that the fog is being modulated using the move forward function, and the interval is actually 1 second right here. In the game, it looks somewhat more impressive, especially when the player remembers the previous events that led to this situation. And let's take one more look at the fog effect, and that should be, I guess, everything about this. And that's all. As you can see, adding a mist effect to a 2D game isn't complicated at all. A capable game designer will surely come up with further possibilities to combine these layers and achieve interesting gameplay situations that will keep the player engaged. Moreover, since all calculations are done on the GPU, we don't have to worry about the mist negatively impacting the performance of our game. Don't be afraid to experiment. So, have a great time, good luck with your game projects, and I will see you in the next video.